Hi everyone, this is the last set of SAT practice for lines, angles, and triangles. The difficulty level is considered hard, and usually that just means there's extra steps that you have to do. We have to find the product of x, y. So basically you need to know some information about your geometries. Opposite angles of a parallelogram are congruent, and the diagonal acts as a transversal that is cutting two parallel lines, so the opposite sides of the parallelogram. So the alternate interior angles formed by the diagonal are congruent. This means that this is 42, that x minus y equals 42, and that x plus y equals 112. Why did I put that? So we can set this up as a systems, and I'm going to go ahead and just add this. You get 2x equals 154. So x equals 77. And substitute it back into either one of these. You can substitute it back into, say, this one, and you're going to get 77 plus y equals 112. Subtract the 77 from both sides, so you get y is 35. Since we have our x and y, you're just going to multiply 77 times 35. This is a calculator problem, and this equals 2695. So it's not that hard. You just have to know your information for geometry. Okay, next we have each of the quadrilaterals is a square. The area of the smallest square is 16. So I'm going to put this as area 16. And the middle square is 48. And we want to know what this larger square is, number 3. So basically, sometimes working backwards is necessary to solve the problem. Here, the areas of the two smaller squares, square 1 and 2, to find the side lengths. So we're going to then work back in the opposite direction to find the area of the smaller one, or the larger one, square 3. So the area of the square is given by the formula area equals side squared. If the area of the smallest square is 16, then each has a length of, so 16 equals side squared, so your side is 4. Since it's a square, all the lengths are 4 here. Okay? Now, same thing for the other one. The second triangle, we have area equals side squared, so 48 equals side squared, so the side is square root of 48, which is the same as 16 times 3. This is side square, sorry about that, which equals 4 square root of 3. So this is a 4 square root of 3. So that means this side here is 4. This side here is 4 square root of 3. And now we want to find this side. So basically, if we want, notice that the figure contained in the 3 squares is a right triangle with 4 and 4 square root of 3. That means it's a 30, 60, 90. If you notice that, you notice you have the form x square root of 3, and 2x. Makes it a lot easier. So my x is 4. Therefore, this would be 4 root 3, square root of 3, which is what we have here already. And then, so this is just 2 times x, which is 8. So this is 8. So area equals side squared. So area equals 64. You could have also used the Pythagorean theorem. Okay, the next one, we have, I didn't write the question out because basically it's just saying this is the figure, and we're trying to find the length of BC here. So it's not drawn to scale, and excuse me on my drawing because I'm just not that good at drawing. So basically what we want to do is we want to add a point, and let's call this point right here, let's call this D. Alright, and that's at the dash line where AC is shown. So this is going to be BD. Now BD breaks the triangle ABC, so this is triangle ABC. It breaks it into two smaller triangles, and you know that two side lengths for triangle ABD, so use the Pythagorean theorem. So what we're going to do is, we know that this side's 4, so this side here is going to be square root of 7. Because this is 4, because it broke it in half. So we have square root of 7 squared plus AD squared equals 4 squared. So basically AD squared equals 9. So AD equals 3. So this is 3. Right? And then all you have to do is notice that CD, I'm going to get this length, it's 8 minus 3, which equals 5. And then we're going to do that again. So we get, use the Pythagorean theorem, you get square root of 7 squared plus 5 squared equals BC squared. So we get 7 plus 25 equals BC squared. Therefore, BC equals square root of 34, which if you break that out, that's 16 times 2, which is 4 square root of 2. So the answer A is correct. And we have one more. We want to know what the value of X is. So we're going to get started on that and try to do it. This is considered the hardest one. We're going to use the Pythagorean theorem first and do this. We have x squared plus x plus 2 squared equals 2x minus 2 squared. So we get x squared plus, and if you FOIL that out, that's going to be x squared plus 4x plus 4. You're just expanding your perfect square trinomials. Same thing here. This is going to be 4x squared minus 8x plus 4. I'm just using my a squared plus or minus 2ab plus b squared when you have a plus or minus b squared. I'm just using that formula. Alright, and you clean all this up, you're going to get 2x squared plus 4x squared plus 4 equals 4x squared minus 8x plus 4. Now solve the equation by moving everything over to the right. I want to move it to the right because I want my x squared positive. So we're going to get 0 equals 2x squared minus 12x. So we're going to factor out a 2x. You get x minus 6. So you have different solutions. We have 2x equals 0. So x is 0, which we can't use that because the length can't be 0. So we're just going to look at this. And we have x minus 6 equals 0. So x equals 6. So basically the answer is C, and this is or 6, and that's a griddable. Okay? Thank you and have a nice day. Bye-bye.